In this video, I introduce classifier-free guidance diffusion models for image synthesis. Classifier-free guidance jointly trains a conditional and unconditional diffusion model without using a classifier. And then the resulting conditional and unconditional scores are combined to obtain a trade-off between sample quality and diversity by selecting strain level, similar to classifier guidance. Suppose that X is sampled from P and Z depend on lambda. The diffusion process Q is a variance preserving Markov process as shown here. This is the transition. P denotes the margin of Z when X is sampled from P and Z is sampled from Q as shown here. Lambda is a log signal to noise ratio, and the diffusion process runs in the direction from lambda maximum to lambda minimum. Condition on sample X, the diffusion process is described by the transition here. The diffusion mean and variance in the diffusion models are defined as here. The reverse process starts from normal distribution, and its transition is defined as here, where V is a hyperparameter. Using the hyperparameterization, here, the denoising score matching objective is defined about the denoising score E theta as here, where E is a normal distribution and Z lambda is computed from X and E, and lambda is drawing from P lambda. The objective is the noise score matching over multiple noise scales. When P lambda is uniform, the objective is proportional to the variational lower band on the marginal log likelihood. Similar to truncation in GANs, the classifier guidance modifies the diffusion score E theta to include the gradient of the log likelihood of the auxiliary classifier model P theta as shown here. This is the gradient of a classifier. Where C is the conditional information and the parameter omega controls the strength of the classifier guidance. E theta tilde replaces E theta when sampling from the diffusion model, as shown here. Because the classifier guidance mixes a score with a classifier gradient during sampling, classifier guidance diffusion sampling can be interpreted as attempting to confuse an image classifier with a gradient-based adversarial attack. Here is some samples generated by using classifier guidance diffusion model. Classifier-free guidance trades off inception score and franchise inception distance score by mixing the scores of a conditional and unconditional diffusion model. Instead of training a separate classifier, the classifier-free guidance trains and conditional denoising diffusion model P theta, parameterized through a score estimate E theta together with a conditional model P theta, parameterized through E theta. A single neural network is used to parameterize both models where C is empty for the unconditional model E theta. And conditional and conditional models are joint trained by randomly setting C as empty with some probability P0. The modified score E theta tilde is computed by using this equation that is explained graphically in this figure. Classifier-free guidance can attain a FID and IS tradeoff. Weak strings reaches the best FID score, while strong strings reaches the best IS score. Here are some samples generated by using classifier-free guidance diffusion model. For more details, please check with these references. Thank you. Bye.